Today, we will take a look as to how can we write equations when the solutions are known. Now, the main idea here is that we can write an equation for a function by analyzing its graph. The idea here is that we're going to be given a graph. In that graph, we're going to identify the solutions. And once we know their solutions, we're going to be write an equation for that graph. So that's the path here. We're going to go from graph to solutions to equation. So let's get started. Now here, before we move on, there's an important concept that we need to understand is that for any graph, the solution for an equation, it's located on the x-axis. And that's very important. It's a very important concept because we're going to use this concept to write the equation. So keep this in mind. The solution for an equation is located on the x-axis. Okay, so now let's look at our first example here. So here we have our graph. The red line is our graph. Now, it says here that we need to write an equation for this graph. All right, so how do we do this? Well, we are going to apply the important concept because we know that this is the x-axis. The solutions for the equation are located on the x-axis. So if we have our equation here, this is our graph. Notice that this graph touches at this point, and at this point, it touches the x-axis. So that means that these 2 points are the solution for this graph. So now, let's see what value of x are those. Well, here, x is -1. And here, x equals -4. We go -1, -2, -3, -4. All right, so at least just looking at the graph, we know the solutions already. So here we have the solution when x is equal to -4 and when x is equal to -1. Now, how can we use this fact to properly write an equation for this graph? Well, we are going to use the factor form. Equation. Now, how do we use this? Well, if we know that x equals -4, its solution, then if we solve for this, x plus 4 equal to 0. If you solve for this, it will give you that x is equal to -4. Now, we can do the same for the other solution. So, because if we have just one solution, then this will be our equation here. But because we have two solutions, then we got to do the same for the other solution. If we know that my solution is -4, then if I solve for this, x plus 1 equals to 0. If I solve for this, I will see that x equals -1. So another way to just remember it is that if you already know the solution, just switch the sign. So if it's -4, you put it as +4. If it's -1, you put it as +1 and set it equal to 0. This is the factor form. If you were to solve for this equation, you would get this, your solutions. But we also want to simplify this. So this is technically your solution, but this is the factor form equation. So the last thing that you want to do is just simplify this. So to properly simplify it, or at least write it in the regular form that you know, we're going to just distribute this. So to distribute x times x is x squared. X times 1 is just x. We're going to distribute this. 4 times x, well, that's 4x. 4 times 1, that's equals to 4. Still equal to 0. Now we solve this. X squared. To simplify, you combine like terms. 5x equals to 4 equal to 0. So if you were to graph this equation, and again, this is a 5, it's just misspelled it. Not misspelled it, it was not written nicely here. Okay, if you were to graph this, you would get this equation. Now, some people might leave it like this: x squared plus 5x plus 4 equal to 0. But technically, because it's an equation, you just gotta set it equal to y. So there you have it. This is an equation. If you were to graph this equation, you would have the shape, and you would have x equals -4, and x equals -1 as your solutions. So let's take a look into another example here. Now, same idea here. You've been given a graph and they're asking you to write an equation for this graph. Well, first things first, locate the x-axis right here. Let me change this into yellow. So here's your x-axis, but most importantly, locate the points where your graph touches the x-axis. So it touches the x-axis at here, and at here. So that means that we're going to have 3 solutions. So let's see, what are those solutions? Well, let's start from that. So here's x1, 2. So when x is equal to 2, and here when x is equals to -1, and here when x is equals to -1, -2, -3, -4. Okay, so we have 3 solutions now. Okay, and again, once you know your solutions, we're gonna write the factor form equation. So what you do is you just flip the sign. So if your first solution is -4, so you're gonna write it as +4. If your second solution is -1, well, you're gonna write it as +1. And the other way, if your solution is +2, now you're gonna write -2, still equal to 0. So what's the deal here? Well, I mean, it's if well, let's say you would have 5 solutions, then you would have to write 5 different factors here. But because we're gonna have 3 solutions, then we write it 3 times. So technically, this is your equation, but we still want to make it into something that is more common. Y equals something. You just don't want to leave it this way. So how do you multiply when you have multiple factors here? Well, one thing that I do suggest for you to do here is that when you have multiple factors, always multiply in pairs. So in some sense, imagine that this factor is not even here. Just imagine that it's not even there. So what we do here, we gotta distribute these 2 factors here. So you distribute this, you get x squared. You distribute, you get x. You distribute once more, you get 4x. You distribute once more, you get 4. So if you were to multiply these 2, you would obtain this. So what do you do with this term or this factor that I said to imagine that it's not even there? Well, just bring it down. Just bring it down. I mean, you're still going to multiply by that. So equal to 0 still. So let's see, can we simplify this? Well, yes, we can. Now that's x squared. That's 5x if I combine those 2 terms. And then you got a 4 here. We have not multiplied the third factor here, so we're going to bring it down. Equal to 0. You're almost done. So guess what? We're going to multiply once more. So let's distribute this. X squared times x. So that's x to the cube. X squared times -2. So that gives me -2x squared. All right. So we're going to distribute this once more. 5x times x. So that's 5x squared. 5x times -2. That's -10x. We're not done. We still got to distribute this 4. So now this becomes 4 times x. So that's 4x. And lastly, 4 times -2. That's -8. Still equal to 0. Let me just bring the calculator down here. We don't really need it. Cool. Technically, this is your solution, but you want to combine like terms. So let's look at here. X to the third. Is there another x to the third that you can combine? No? Well, let me just bring it down here. X to the second. I see that I can combine it with this x to the second. So if you combine them, -2x to the second plus 5x to the second, that gives me 3x to the second. So that's fine. Let's see, is there anything else that we can combine? I can notice that here we have this x's here. So -10x plus 4x, that's -6x. This is -8. There's nothing that we can combine it, so let's just bring it down here. Still equal to 0. So technically, this is your equation. You can write it this way, but let's just set it equal to y. Because this is the standard form equation here. All right. So, oops, not this. So this is pretty much it. All you got to do is just go from solution, identify the solution, which you can identify them on the x-axis, writing down on the fact from equation. Once you have it in this form, then it's just a matter of multiplying, but always multiply in pairs. If you have three equations here, well, just do two at a time. Multiply these two, whatever the result is, multiply by the third one. And don't forget to combine like terms. So that's pretty much it. Here is your entrance ticket. You've been given this equation, this graph. Write an equation for the following.